Hello and welcome back to Frogger here. So it's been several weeks since I released this episode, but I was thinking about it, and I think this would be a good place to show off custom resources for the first time. So the way that we ended up setting up our obstacles in this game was just to have a global autoload script and have a bunch of dictionaries with all their information. But another way that we could do this would be to have a custom resource where we hold all this information in resource files for each individual type of obstacle. So I'm doing this bonus episode here to show you guys how I would go about turning this type of structure, instead of using dictionaries, to use custom resources instead. And if you noticed from the way that I had this set up last time, I've changed obstacle type enum here to obstacle type in, is this called Pascal case? But it's not. Enums, apparently by the GDScript style guide, aren't supposed to be all caps. They're supposed to be, I believe this is called Pascal case, where every word is uppercase, but not the whole thing. So let's go ahead and convert this into a custom resource instead. So let's create a folder here, and we'll name this obstacles under our resources folder. And in here, we'll create a new script, and we'll call this obstacle data. So let's have a class name here, obstacle data, and this will extend resource. So we're making a custom resource by extending resource here. And for all of the variables that we want to have, we're just going to have export vars. So we're going to have the scene as a pack scene. We're going to have the speed as a float. We're going to have the spawn time range as a vector 2. And we're going to have the obstacle parent path as a node path. And a thing about resources is you can't actually reference nodes that are in your scenes in a resource. If we, like, for instance, if we wanted to do obstacle path or obstacle parent directly as a node 2D, it won't let us do this in a resource. It says node export is only supported in node derived classes, but that the current class inherits from resource. So we can't actually reference a node in one of our scenes directly as an export variable in a custom resource. And the reason behind that is because it's some backend stuff with resources. This can't serialize correctly. What were some of the reasons? Yeah, a custom resource cannot safely store references to scene nodes like a node 2D. So resources are scene independent data containers, while nodes only exist inside of the scene tree at runtime. And because of that, exporting a node 2D directly inside a resource usually won't work, or it won't serialize correctly. So a way to get around this is we're just going to give a node path to the node that we want to get, and then we'll have a function here. We'll do get obstacle parent, and we can call this at runtime, and this will return us that node 2D that we're looking for. So we'll do return owner dot get node, and we'll give it that obstacle parent path. So that's our way around not being able to reference a node 2D directly inside of a custom resource. So now that we have our custom resource obstacle data, all we need to do is come into our obstacle folder here and create a new resource. Instead of a script, we'll create a new resource, and this will be an obstacle data resource. So this is our custom resource that we created, obstacle data, and we'll do obstacle car. So in here, we can have all of that information that we had in our dictionaries here, but instead it'll be all contained in a resource file that we can reference. So let's come to our obstacle scenes here, and we'll drag in the car obstacle scene. Give it a speed of 100. The spawn time range is 0.4 to 3.5. And then here we can give that node path to obstacles above. And so we can do this for all the other obstacles. We'll create a new obstacle data here, and this will be obstacle cat. So we can drag in the cat scene here. Its speed is 75. Its spawn time range is 0.8 to 7.0, and then we can assign that obstacles above parent node path. Let's create another resource, obstacle data resource here, obstacle snake. So we can drag in the snake scene, and it's got a speed of 90, 2.0 and 7.5 for the range, and then we can assign it to obstacles above. And we got 2 more obstacle datas here to create. So obstacle log. Drag in our log scene. It's got a speed of 60 and a spawn time of 1.5 to 7. And then that's obstacles below. And finally, our last custom resource, obstacle data resource here, is going to be obstacle turtle. So we'll pull that turtle scene in. It'll have a speed of 50 and a spawn time of 2.0 to 7.0, and assign obstacles below. So now that we have all of our obstacles as custom obstacle data resources, we can go ahead and use those in the obstacle manager. So instead of the obstacle type being the global enum, we will have it be obstacle type of obstacle data. And here we will say obstacle data. Let's change this to obstacle data. So obstacle data dot scene. Do obstacle data dot spawn time range. Obstacle data dot get parent, or get obstacle parent, and then we'll do get node root game, because that is the owner of the obstacle parents that we're looking for. For speed, we'll just do obstacle data dot speed. And that's all we need to do to change this to using custom obstacle data. Actually, finally, one last thing we need to do is change the obstacle managers. So before we were just having the drop down and we could choose what type of obstacle we wanted. That part was nicer. But if we were to scale this to, like, let's say dozens or even hundreds of types of obstacles, our global script is going to balloon out of control. And this part of it would be, you know, hundreds of entries per dictionary or dozens of entries per dictionary, hundreds of preloaded scenes. And instead of doing it that way, we could just have 100 custom resources here in one folder, and it wouldn't, this one individual script wouldn't balloon out of control. So obstacles are really good. Like, for instance, if you're doing an item system or a crafting system or something like that, you could have hundreds of items and you could have hundreds of crafting recipes, and they'll all be contained in one folder instead of having one script that just balloons out of control. So for our obstacle managers, let's hold control here and we can select these first 3 ones and drag in the obstacle car obstacle data, or the obstacle car custom resource. For these 2, this is also car. These 3 and these 2, these are all cats. Drag those in. These 2 here are snakes. all of these up here are going to be logs. And these three are turtles. So now instead of using that global enum, we're just dragging in the obstacle data itself for each one of these. And that should be enough to get us switched over here to the custom resource. And there we go. Everything's working exactly the same, but you know, that's how custom resources work. They're just basically ways to store data. So this system is way more extensible. You could have dozens or hundreds of obstacles, and it's not going to clutter up your, you know, this one global script. We actually don't need this global script at all anymore. And it's just, it's a little easier too to create a new obstacle. You know exactly what you need to give it to create a new obstacle here. We'd need to give it a new scene, a speed, a spawn time range, and what obstacle parent it goes under. This is all the data that you need to define a new obstacle. So I just wanted to show you guys custom resources real quick. And in the future, whenever we're doing a project, I'll try to identify places where, you know, custom resources would be applicable, and try to avoid doing something like this in the future. This worked for this project because it's just, there's only 5 obstacles, and it's really small and limited. But like I said, when the number of obstacles starts growing, then this type of implementation stops being as effective. So yeah, I hope you guys learned something about custom resources and how powerful they can be. And I'll catch you on the next one.